Hello everyone. In this masterclass, I will tell you what is a permutation, what is combination, and what is the difference between permutation and combination. So let's start with the simple thing. The simplest way to remember the difference is nothing but whenever order matters, then permutation will come. Whenever order does not matter, in that case, combination will come. So now what is the meaning of order matter or order does not matter? So whenever we are finding any arrangement, sequence, and position, okay, whenever order matters, so when the order matters, let's see first of all. So for example, you have to make the passwords. Let's say if I give you four numbers, 1 2 3 4. So by using these four digits, how many different passwords you can make? Let's assume you have to pick up any two numbers. Out of this four digit, you have to pick up any two numbers and make the password. So what different kind of passwords we can make? We can make it 1 2, 1 3, 1 4, 2 1, 2 3, 2 4, okay, 3 1, 3 2, 3 4, 3 3, 1 1, 2 2, 4 4, okay. So many passwords we can make. But what is the meaning of here? Is this 1 2 and 2 1 is same? Password 1 2 and 2 1 is same? No, right? So here order matters. 1 2 and 2 1 both are the different passwords. So whenever order matters, that is called permutation. And when the order does not matter, in that case combination will come. So the definition is very simple. When changing the sequence, change the result. That is called permutation. For example, here 1 2, if you change the position 2 and 1, so result will change. This 1 2 and 2 1, both the passwords are different. Okay. So when the order matters, that's permutation. Look at the next thing. So when permutation, where we are using actually. So whenever we have to give the ranking first, second, and third, that's nothing but a permutation. For example, sitting arrangements, we have to arrange the sittings of the five students in a five specific row, chairs in a row. So that is nothing but the permutation. Okay. Now our second part of the topic, that is combination. So we have just seen combination means order does not matter. But what does that mean, order does not matter? So look at this mixture. Suppose you have, let's say, fruits, banana, strawberry, apple, and grapes, and let's say mango. So you have five fruits. So you have to make the juice by using any three fruits. Okay, any three fruits. So if you take banana, strawberry, and apple, okay, together, or first you take banana, then you can take strawberry, and then you can take apple. So the juice will be same. Whatever, if suppose you are taking first banana, then strawberry, and then apple. Then second time, you if you take first strawberry, then banana, and then after that apple. Okay. And the third time, if you take first apple, then banana, and after that strawberry. So what is the difference here? In all the three cases, the juice will be the same. Okay. So here order does not matter. If you take BSA, SBA, ABS, in all the three cases, this all the three fruits are mixed up. Okay. So fruit in the end, the result will be the same. There is no change in the result when you change the sequence. Okay. So that is the combination. When the sequence doesn't change our result. So that is nothing but our combination. Understood? So where is the use of this combination? So for example, whenever you are selecting a team, when you are shaking the hands, or let's say topping up pizza, suppose you are first of all mushroom and chili if you are adding, or first you are adding chili and then you are adding mushroom. So it doesn't matter the uh, end of the result. Okay, it will be the same thing. So that's the combination. So we have seen the difference. Now let's see how to find out or how to solve that permutation and combination. So this is the main key feature and difference. Whenever you have to arrange the items in the order, use permutation, and whenever you have to select the items from the group, you have to use combination. So in general, we are writing like this: NPR. NPR means from the n items, you are selecting any r items. And for combination, we are using C. NCR. That means from the n items, you are combining any r items. Okay. So whenever order matters, use permutation. So the formula is given by NPR is equal to n factorial upon n minus r factorial. And in case of order does not matter, the formula we have NCR is equal to n factorial divided by n minus r factorial multiplied by r factorial. Okay. So for example, permutation, passcodes to make the passcodes, passwords, podium ranks, or word formation. And for combination, team selection, lottery numbers, fruit salads. Okay, these are the examples. So let's look at some examples how to solve. So before that, this is the example of the difference. So suppose you have to choose any two letter from the alphabet A, B, C, D. Okay, choose any two letters. So what is the different type we can choose? So in case of combination, order does not matter. Okay, so AB and BA both are same. So when you write combination, A and B, B and A both are same. So A comma B we have written only once. Then we can take A comma C, A comma D, B comma C, B comma D, and C comma D. So these are the four different combination that we can make. So total 6 ways to select any two letters out of 4. Okay, this is a combination. Now permutation, what is a permutation? So if you select any two, so AB and BA both are the separate thing. Okay, so we have to count AB as well as BA. Now we are taking AC, so you have to count CA also. AD, then you have to count DA also. Okay, so here actually double of that. Okay, so total 12 ways to arrange two letters out of 4. So this is a permutation. Here order matters and here order does not matter. Okay. So now the trick how to find out the permutation. So we have seen the formula, that is NPR. The formula is simple, n factorial upon n minus r factorial. So if you don't know the factorial, I will tell you first of all. So let's say 4 factorial. So 4 factorial is nothing but 4 multiplied by 3 multiplied by 2 multiplied by 1. Okay, you have to subtract one digit, one number, and you have to multiply all that numbers till 1. For example, 3 factorial. So 3 factorial is nothing but 3 into 2 into 1. Okay, backwards, like that. So without using this formula, we can actually calculate. So what is that way? Suppose we have to calculate this. Look at this example, 5p2. So we have to calculate 5p2. 5p2 means out of 5 object, we are selecting any 2. So what is the total number of ways? So 5p2 is nothing but, here the number is 5, total 5 objects. So you start with 5, then decrease that number by 1. So it becomes 4. Okay. So only 2 digit you have to write down. Here it is 2. So write down only 2 digit. Whatever the second numbers is given, till that much digit you have to write down. Okay. So 5p2 means 5 multiplied by 4, which is 20. Look at another example, 8p3. So 8p3 means, here it is 8, so you have to start with 8, decrease by 1, so 7. Okay, look at this number, second number also 3. That means you have to write down 3 digits only. So 8, 7, and after that 6. Multiply all the numbers, so you will get 336. Similarly 10p4. So first number is 10, start with 10. Second number is 4, that means you have to write down only up to 4 digits. So 10, decrease by 1, 9, 8, and 7. Done 4 digits, multiply these 4 digits, you will get your answer. Okay. So this is about permutation. Now how to calculate combination? So we have seen that in the combination, order does not matter. So the results will be little bit smaller as compared to permutation. So suppose we have to calculate 7c3. Okay. Formula we have seen n factorial upon n minus r factorial into r factorial. Okay. You can use this formula also to solve, but without using the formula, how to calculate directly. So suppose let's say 7c3. So look at the first number 7, second number is 3. So the same thing, write down 7, then 6, then 5, 3 digits. How we are doing in the permutation. Now here extra denominator is there. So in the denominator you have to look at the second digit is 3. So write down that is also till up to 3 digit. 3 multiplied by 2 multiplied by 1. 3 factorial. So if we cancel out 3 to the 6, so 7 into 5 which is 35 is the answer. Similarly look at the second example 10C2. So 10 you have to start with 10, then 2 digits you have to write down. So 10 multiplied by 9. And in the denominator second digit is 2, so 2 factorial, that means 2 into 1. So if we cancel out 2 5s are 10, so 5 9s are 45. Okay. So one more question you can see, this is a result actually. Suppose you have to calculate 50C48. Okay, 50C48. So this is quite a big number. 50C48, this is quite a big number. So if you solve actually what you have to write down, you have to start with 50, then second number is 48. So you have to write down till 48 digit. Okay, so that is quite lengthy. So in this case what we can do, symmetric mirror. Okay, so 50C48, that we can do like this, 50C2, just subtract 50 minus 2, 50 minus 48. Okay, so 50 minus 48 is what? 2. So we can calculate 50C2. So what is 50C2? 50 multiplied by 49. Since here it is 2, so 2 digits we have to write down upon 2 factorial, which is 2 into 1. Okay. So 2 25s are 50. Then by multiplying this number, we will get our correct answer. Okay. So this is a result, symmetric mirror. For example, see, look at one more example, 12C9. Okay, so both the number are very big. So what you can do, 12C, just subtract 12 minus 9. What is 12 minus 9? 3. So we have to calculate only 12C3. So 12C3 means what? 12 into 11 into 10 divided by 3 is there, so 3 factorial. That means 3 into 2 into 1. Okay. So by solving this, we'll get the answer. So this is a symmetry property. Whenever you are getting the massive number, just use this property to calculate combination easily. So some results are there. NC0. So NC0 means out of n object you are selecting nothing. Okay, so that is only one way. So NC0 is 1. Similarly NC1, NCN. NCN means from the n object you are selecting all of the n object. So that has only one combination. So NCN and NC0. The answer of both the thing is 1. The next third one is NC1. Okay, so out of n object selecting only one object, so that type of combinations are n. So NC1 is nothing but n. Okay, selecting one item from the n choices, that will give you n options. Okay. For example, you have 4 option A, B, C, D. So you have to select only one option out of 4. So how many choice here? 4, no? So 4 option, 4 choices. So NC1 means n. Then NCN minus 1, that is same as n. Okay, NCN minus 1. For example, 5C4. Okay, so difference between this and this number is 1. Sorry, yeah. So 5C4. 5C4 is nothing but same as 5. Okay. Similarly, NC2. NC2 is nothing but nn minus 1 by 2. This is derived from the formula. Okay, so this we can use whenever the handshake formula actually it is called. Okay, whenever n objects are there and you are combining any two, okay, unique pair of the connection. So this is called handshake formula, NC2. So look at that handshake formula in the real life, how we are applying that. So let's say if 10 people in a room all shakes the hand with each other exactly once. So how many total handshakes occurs? So to find out the total number of handshake, actually we are using combination. Okay. So the logic behind is a handshake is just a combination of two people. Here order does not matter. Okay, person A shaking with the person's B hand is exactly same as B shaking with A's hand. Okay, so here order does not matter. So this is nothing but the combination. So total how many people are there? 10. Okay, so for the one handshake they require 2 hands, correct? So 10C 2. Out of 10 people, one handshake required 2 hands. So 10C2. So how to solve 10C2? 10 multiplied by 9 divided by 2 multiplied by 1. So if we cancel out 2 5s are 10, so 5 9s are 45. That means total 45 handshakes occur in this meeting. So this is a practice question for you on this permutation and combination. Try it and comment your answer in the comment section. Thank you.